All right, part two of this kind of virtual lab, as I'll dub it, we'll look at the creating a PanelView Plus 6 application, kind of the steps that we would need to take to develop a simple touchscreen application. And more specifically, the idea is, in the lab with the control object stations, we have the 15-inch PanelView Plus 6 at each station. So it's a very nice large size touchscreen. We didn't use the Siemens ones because they were smaller screens, 4-inch screens. So, my thinking has always been that the bigger screen is a little bit easier to work with and a little bit nicer. So we just kind of saved it for when we got to the control objects part. So the idea is that the 15-inch panel view is sitting at each station. It's connected to the control objects over Ethernet, and so each panel view would basically tie into that control objects and read tags and data out of the control objects, and you can display it on the screen. So for this little walkthrough, we're going to kind of go with the premise of we're going to create an application where we want to put a start push button on the screen. We also want to put a stop push button on the screen, so the operator can now press the button here on the click panel, or I'm sorry, on the panel views plus 6, or the operator could also use the physical push button that's maybe on the console, control console, so he can be at the touch screen and press start or stop, or be at the operator console and press start or stop. Also on on the touchscreen, we will show a couple of just some statuses. So we'll show engine running status, engine fault status, and engine speed status. So fault and running are simply a discrete contact, so either on or off. Engine running would be an actual numerical value, since it has a speed value to it. All right, so step one. I did do a video previously that showed how to actually create a project from scratch. So this kind of picks up from where that video would have left off. So we're going to assume you've already created the project. You've already configured it as a 15-inch panel view, and now we're going to really get down into the meat of how we're going to program or create the application. So typically, our first step would be connecting the controller to this panel view. And then we do that under the communications settings, which was underneath in the navigation tree where it says FactoryTalk links. So FactoryTalk links, we double click on it, and it pulls up the window we kind of see popped up there. And if we were connected to the controller, we would actually have like RS links would fire up, and we would see all the devices on the network that are connected. So we'd be able to actually go and choose the actual controller there in the lab that we were connected to, select it, and that would make the connection from our panel view to that PLC. We have to hit the add button, which is about right there. Now we're offline, so I'm not at the lab, and neither are you. So the situation is we're not always connected to the equipment, so we're offline. So we could still create a path and give it an IP address essentially. But the more important thing is right here. We want to create the offline tag file. So the ACD file that we've been using for our Studio 5000 control objects project will actually point to that ACD file itself, and the panel view, this software will actually pull those tags out of that ACD file for us to browse. So this actually shows a little bit better zoomed in. So I'm giving it the path. The name of the ACD file, again, which is the Studio 5000 file, was ELET 287 demo, right? So that was my ladder logic from the previous part 1 part of this virtual lab. So I'm just going to simply again point to that file, and then at that point all the tags will be available. So offline tags, they call it. If we were actually connected live to the real equipment, it can actually pull the tags right out of the controller online. So there'll be the online tags as well as the offline tags. Okay, so we got our communication path set up and we've got our offline tag database set up. So now we can actually go in and create the display. So the red box on the left shows where the graphics panels are. So they call them graphic panels or displays, or graphics and displays. So the actual, each one of these screens we create would be known as a display in the software. So for instance, we could have a main display. We could have a generator 1 display. We could have a generator 2 display. And we can just kind of create navigation buttons to kind of go between all these displays. So that's another very important part of developing for HMIs, is you have to kind of know your navigation structure to kind of go around, right? So in this case, we're keeping it simple. We're going to have just one screen, which will be the main screen. And it's called main by default. You can, of course, change that. And as main would imply, this would be the first screen that pops up when we power up this panel view unit. So we have to kind of set a default screen that it goes to, and typically main would be that guy. It's very much like the home page on a website. So we just double click on main, it pops up the main display there in the box, and we can start adding elements to it, or objects as they're actually known in the software. So the first object we want to add is just a simple, perhaps a little title to the page, right? So the operator knows that when he's on that page, what is the page for. So so there's a text box on the menu bar. We could click that, and then I'll pull up the text properties, and I can just type in text in that white space there. So engine generator control panel is what I'll name it. You also see we have the ability to change some things, such as the font. We can change the alignment. We can change the size, bold, italics, underline. Right, so we can give it some various properties to change the look of the text, and color too. We can change the color of the text. So this is it. So I typed in that. I went ahead and made it a little bit bigger so it kind of stands out. And if I want to make any changes to it at this point, I can just double click on the string, and it'll pop up back that text box that we just had on the previous slide. All right, so next step is, let's go ahead and add a push button to the screen. So we want to add a push button such that when I walk up, and if I press this push button right here, it will send a start signal to the generator. And we will also create a duplicate push button that when I press it, it will send a stop signal to the engine. So what we do is there's all the menu items up top, and if you put your mouse over it in the live software, it'll give you the little pop-up of what each one of these are. But this guy right here is the momentary push button. So when I say momentary, that means that when my finger's on it, it is on. As soon as I take my finger off, it'll go back to off. There is a maintain push button right next to it. We'll use momentary. So what we do is we click the momentary button up there in the menu. We come down, we kind of just drag out a square rectangle type space, and there's our button. It's blue by default. We can change that. We can also change the size at any time, resize the button, change the color, all that stuff. We do that by right-clicking on the button, or I'm sorry, double-clicking on the button. We're going to double-click on the button in this case, and that'll pull up its properties. And we really have two things we want to look at here. First is the States tab. So the States tab means like the states of the push button. So this push button has two states, and what we mean by states here is, what are the states of the push button? So in this case, it's either off or it's on. So state 0 is off, state 1 is on, 0, 1, off, on, discrete push button. And then the caption, we can change exactly what the button will say. So we could put words or text inside the buttons box, that's known as the caption. So we'll just call this what it is, Start Engine. If I want to change the colors, I have that ability here in this states. We can go down here and change image back color and stuff like that. So we have the ability to completely customize the button and make it look in different colors for various tasks perhaps. And then when we've got that kind of controlled, we look at the connections tab. So we can click on the connections tab, and this is where we'll actually link it to the tag in the controller. So again, we've made the connection between the panel view and the controller. That's typically over Ethernet. Now we have to actually link this button or this object to an actual tag in the controller. So that way we know that when I press that button, it will send a signal to that tag. So we had the offline database set up back there in the communication setup. So if we click on the tags, we can now go to the offline folder, and when we click on offline, which is right here, we'll pull up the tags that are in the controller. So if you look at that box that I highlighted in red, those are all the tags that I created, all the alias tags that I created in the control objects back there in part 1 of this lab. Now, let's kind of halt right here, because just think about what we're doing and what we're saying we're doing here. We're going to send a signal from the panel view to a tag in the control objects. So your natural inclination would be, well, let's just write the push button right to the tag that we've already created. We already created a tag called Start Push Button, or Engine Start Push Button. We also created a tag called Engine Stop Push Button. We cannot link our button to that tag, and the reason why is because that is actually tied to an input card. Remember, that is actually an alias for the local 1i data.0. So what's happening there is that is an actual physical input in an input card. And the way how the PLC does its sweep is at the top of every sweep, it goes and it reads the input table from the actual physical I/O cards in the rack, and it writes their values. So it's a 0 because I'm not pushing the actual real push button. So every time it comes to the top of the sweep, it says 0, 0, 0, 0. If I'm trying to use my panel view push button to write into that same tag that is tied to the actual real physical push button, it's going to be constantly overwritten by a 0 every time, because the PLC is, by its nature of how it operates, it's sweeping, reading the inputs in order of milliseconds. So we cannot use that same tag. We will have to create a separate tag for the panel view to write to. So, and I also want to make that distinguish that here at this point too. Every tag has the ability to be a read or read-write. So if it's a read-only tag, then I can read data from the PLC all day long. I don't need to go create separate tags for reading. But if I want to write to a tag, and if it's tied to an actual physical input, like in this case, I got to create a separate tag, totally separate tag that's not tied to physical input card to be able to write to it, okay? So how do we do that? Now I'm going back to Studio 5000. I'm going to create 2 new tags in my controller. I'm going to call one Remote Start. I'm going to call the second one Remote Stop. And they're both Boolean tags because, again, it's a push button, so it's either going to be on or off. There's nothing in the alias, nothing on the base tag, but they're not going to be alias tags. It's just going to be a separate tag in the controller. I'm going to use those tags in that rung 0, basically the initiate rung. And what I want to do is I want to take my remote start push button from the panel view, and I want to put it in parallel with my physical engine start push button, right? So it's either or. If I press the physical push button, or if I press the panel view push button, start the engine or initiate the sequence. For the shutdown, remote stop, I'm going to put that in series with the other shutdown conditions, right? So I had the physical engine stop push button, normally close contact, in series with the engine fault contact or bit, normally close. And now I'll put in series with that the remote stop. So if any one of those three things happen, it breaks the latch for the initiate. Okay. So made the change to the rung, we downloaded the program to the PLC, and now we're ready to go. So now we come back to our panel view application in the FactoryTalk machine edition software. First thing we got to do is we need to do the refresh all folders button. So right here, we have got to press this button in order, there you go, in order to find those two new tags we created. If I don't hit the refresh all folders, it's still living with whatever data is in the offline folder from the previous time I did a refresh. So if you don't see your tags there after you created new ones, do the refresh all folders button. When I do that, at the bottom of the list, remote start and remote stop now show up in the list. So after I do that, I just select the tag. In this case, I want to select remote start. Remote start now goes into the tag/expression field there on the connections tab. So again, when I press the panel view push button, it will actually write a 1 down to the remote start bit. And if I take my finger off of it, it will now go back and write a 0 into that bit. Okay, so we have a push button. Now we can simply duplicate that push button or copy paste it. So we can select the engine start push button. We can do a copy paste, or we can do a duplicate. And I can now create a second push button quickly and simply. So I already got a push button set up. Maybe I already got the size set up right. I got the color set up right. So now you can just duplicate or copy paste, and then go back, double click on it, change its caption to be, I put start stop. I made a typo there, should have been engine stop. And I can also change its tag expression to be remote start tag in the controller. All right, so we've made the push buttons. Now we want to add some indicators. So indicators are going to be simply a just displaying a value, just displaying a value of a tag on the screen. So now that's a read. Okay, so if we're just going to be displaying something, we're just reading the data from the controller. So if I'm just reading the data from the controller, I can read those alias tags that are directly tied to outputs on the PLC. I don't need to go create separate tags to do reads. So how do we do this? Several ways to do it, but one way I'll show you is just to create a simple object of a shape. And I'm going to create a circle because that's usually, pilot light indicator is typically circular. So I'll make a circle on the screen. By doing that, I can come up here to the menu and the drawing objects, and we got the circle right there. And then I just draw a circle right here on the screen. And then once I draw a circle, I right click and I choose animate, and then I choose color. And that's going to allow me to animate the object, its color property. So I can change its color property based on its state. So this is what the animation property looks like. It looks a little bit different than the properties we showed earlier for the push button. And in this case, we have a lot of different animation properties kind of showing in tabs up there. We have fill and touch and color, visibility, rotation, width. We have a lot of different things we can actually animate this thing. So we could do a lot of different things with the animation. Again, we could make the whole button, the whole thing go invisible until a certain thing is true, and then it pops up. We can make it actually physically move across the screen for some reason. So we have a lot of capability. But to be a simple indicator, we just wanted to change color, like a light. So if it's off, be one color. If it's on, be a different color. And then tie it to a tag in a controller that, based on the state of that tag in the controller, that's what's going to tell the light to be either red or green. Now, typically we use green for off and red for on. Of course, there's a lot of different conventions for that, so that depends. So I flip-flopped the states 0 and 1 such that state 0 or off is green and state 1 or on is red. And then I also tied it to the tag engine running. So I just simply chose the tag button right there. And I went to the offline folder and I chose the engine running tag and put it there. You hit apply and then close. So if engine running is on, the light will be red. If engine running is off, the light will be green. And there is our indicator circle. Now it shows teal right now. It's because it's just the default color. It won't actually go into its animation 0 or 1 color until it's actually running the application. I also want to put a label over it. That way I know what that thing is, right? If I just put a circle there, no one's going to know what that is. So I put a simple little text label above it that just basically says engine running. Just like we did for the push button now, I created one indicator. I can copy paste that. I can duplicate it. So now, again, the circle might be the right size. State colors are the right colors. We can copy paste and just change its tag to be to the other tag that you want to tie it to. The other tag we were going to indicate was if it was a fault light, right? So engine fault. So there we go. Did a copy paste. Now I got my engine running and engine fault indicators, and I got my 2 push buttons, start and stop. So last piece would be the numerical display. So there's some built-in numerical displays up top on the menu, and this guy right here in the red box is the kind of the standard numerical display. So if I click that, and then I come down here and I just drag a box, like we did a push button, I can make that a rectangular shape. I can resize that box to be bigger, smaller, whatever. And then I gave it a little label above as well, engine speed. Now you see it says a bunch of ins there. That's just kind of a placeholder, but that would be live data when we're running. So it actually will be reading the engine speed tag, which is being tied to an actual analog input, and would display that number, which is the scaled value in that box. So to do that is simply double clicking on it, getting into its properties, and then going to the connections tab, choosing tags, and then scrolling through the offline folder again and tying it to the engine speed tag, and that's it. Now, common, general, you can change all the color properties of that box. Or it was blue by default. So if you want to change the colors and the fonts and the size, all that will be done in those other 2 tabs. All right, so now we got our simple screen completely built. Now we want to test it. So there is a built-in way to test it without having to actually have a panel view attached to your computer. So the little guy up top, he's called the running man, but that's basically the test application button right there. So you click the test animation button. It will compile it. It'll validate it and make sure there's no errors, and then it will compile it, and then it will pull up the runtime window right there. So there's, in the red box, is the actual application running on my computer. if I was actually tied to the real PLC in the field, if that was on my, if I was on the same network as that PLC, or if I'm on the bench, had the PLC just sitting right next to me running the program, everything you see on that, all those buttons, all those lights, indicators would be live data. So it actually would be getting live data. So I can really test out my application without actually having to have a panel view, with me. Very nice feature. So just a little note at this point. So if this was really in the lab, we want to do really two more things to finish this off. First step is we'd have to create what's called the MER file. That stands for Machine Edition Runtime File. That is the compiled file that would be loaded onto the panel view itself, and that would actually be the guy that runs on the panel view. So we would do what's called create the MER file. So basically, when we do that, it'll compile it. Well, again, it validates, checks for errors, then it compiles it, and it saves it again as a .mer file. So whatever the project name is, .mer. Then the next step would be to copy or transfer that MER file from your computer to the panel view. So if we're connected to the panel view on Ethernet, we can simply download the MER file to the panel view. If we maybe didn't have that capability, we can actually put the MER file on a USB stick, bring the USB stick out to the panel view. There are two USB ports on the panel view. Stick the USB stick in there, and then we can kind of get into the menu on board the panel view itself and copy a file off of the USB stick. So that's kind of a nice feature as well. You don't always have to have a computer to change to send out a new file to the panel view. Ideally, you want to use your computer. It's just easier for the most part. So that's the process. So we got to create the MER file, and then we download the MER file to the panel view. And after the download's done, typically the panel view will reset itself, reboot, and then the new application will come up and running. So that would have been what we would have done in the lab. We would have worked on some ControlLogix programming examples and had you guys, did kind of just use the stations and come up with some programming examples. And then we would have overlaid the operator interface panel view onto that, and we would have started using the panel view to kind of, get some visual indications and some control of some things in the program. So anyway, I hope that helped. Maybe demystify some of that stuff a little bit. I know it's really challenging when we can't be in there, and if I could show it to you live, it would instantly click. It's a little bit harder to try to describe it without actually seeing it. So, all right, that's enough for this kind of virtual lab. Just any questions, of course, just reach out and let me know.